Hey guys, this is Mr. Lowry. I wanted to just briefly introduce this activity that we did in class because it is going to be for points in the gradebook. So if you missed class on day 2 of this week, this is what we did, and you're going to need to do this on your own for points. So this is the third Zombie Week activity that we're starting here. This one is a comparison between exponential growth and linear growth. And in the story here, where we left off, the first day we were analyzing exponential growth, and we made models to predict when the zombie population was going to get too big. And then in the day 2 activity, we predicted when the radioactive fallout was going to be below a safe level. So in this part of the story, what's happening is imagine that you on your team of analysts are going to a remote research facility, and you're working on a cure for the virus. And as that's happening, some of the zombies break out and start infecting people in the laboratory. So you can read this on your own, but that's kind of the gist of it. And there's 3 tasks here. There's task 7, which is creating a table, and then there's some questions here for you to answer. Task 8 is to create a graph, and then task 9 is write a function. So very similar to what we've done in the other tasks. Okay. The difference here is that you actually have 2 different populations. So notice that in this table you have a zombie population and a human population. Okay. In the story, if you go back and read it, you'll see that there is a group of zombies that are being healed and like turned back into humans. They're being cured. So the human population is growing as zombies are being cured into humans. And now there's a totally separate population of zombies that's growing because there is a zombie that got loose and he's biting people. So 2 separate groups of zombies and people. One, you got humans turning into zombies, and over here you have zombies turning into humans. But we need to keep these groups separate, otherwise this task gets really hard. Now here's what's going on. Zombie population is doubling. Human population is growing by 50 every hour. Okay, so if we start filling out this table, the next guy in the human population, the next number should be 104, right, and then 154, and then 204. We started with 4 like scientists, 4 humans in this lab, and there's a bunch of zombies that we're curing, and they're turning back into humans, and this is the rate. So notice the pattern here, that every time we go up an hour, we have 50 more humans. Okay, that's what's going on. Now, over here in the zombie population, we got a different pattern happening. And here we're doubling. So we got 1, 2, 4, right? 4 is going to double. We're going to get 8. And then we're going to double again. We're going to get 16, and so on. So that's what's happening here. Now notice the pattern's different. We're multiplying by 2 every time an hour goes by. Okay, so this is what's called a linear pattern. There is a constant rate of change, meaning I'm adding the same amount every single time. The difference between each of these numbers is the same. Here, there's not a constant rate of change, but there is a constant growth factor. So here I'm adding, here I'm multiplying. Okay, that's the difference. So you're going to keep filling out this table, and you're going to answer some of these questions about what's happening with the population. So those questions are kind of down here at the bottom. Okay. Now one of the things it says in the story is if the zombie population ever gets bigger than the human population, then the zombies are going to take over the lab, and you're going to be done for. Okay. So what we want to find out as we complete this table is we want to find out when the zombie population is bigger than the human population. So right now, at 4 hours, there's 16 zombies and 204 humans, right? At 5 hours, if we want to continue, there's going to be 32 zombies and 254 humans. So we keep that pattern going, and we want to find out when this number ends up being bigger than this number. And that's kind of what we're looking for. That's kind of the point of no return. Okay, task 8 is to create a graph. and it has some some instructions here. It tells you how to scale it. It tells you how to label your axes. So you're going to make a graph. Now in this one, in class we did a graph. Everybody did their own graph. We didn't use big paper. So let me grab some graph paper and show you how you're going to do this. Okay, so let me help you get started. It says here that we want to label the x-axis hours passed and the y-axis population of humans or zombies, because we're actually going to put both humans and zombies on the same graph. Okay, it tells you how to scale the axis, and then we want to label this point of no return when the zombie population becomes bigger than the human population. Okay, so let's start out with our graph paper here. I will put a link to where you can find this graph paper online. You can print it out. So down here we have hours, okay, and up here on the y-axis we have population. But remember, we're doing humans and zombies, so we're not going to put zombies or humans. It's just population in general. We'll just leave it kind of generic. And here's the amount of hours that passed: 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Okay, and then going up this way, we're going to have population, and it says to scale it by tens. So 10, 20, 30, 40, 50. Now, scaling by 10 doesn't necessarily mean you need to write every single number. So each line represents 10. That's what scaling means. But what I could do is go like 60, 70, 80, 90, 100, right? Like you can do it like that. It's still scaled by tens because every line represents 10. It's just a little bit less writing. And then you know, okay, that's 60, 70, 80, 90, 100, right? You do the same thing here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 200, right? So something like that. You could even put a halfway point, 10, 20, 30, 40, 50. If you want to do, you could like, okay, I'm going to put 150 there in the middle. So it's kind of up to you how many numbers you write, but each line will represent 10, okay? What's going to happen is you're going to run out of room kind of quickly because we need to kind of go up a little bit higher than this graph will reach. So what you're going to do is you're going to take another piece of graph paper and you're going to like put these together. So you're going to trim off the bottom, trim off the top, line these guys up so that your graph can keep going, and then your scale will continue to go up that way. Okay. Now let me help you with the points. Okay, plotting the points. The table here is actually two tables in one. Okay, this is the x. This is the x here, the hours, right? This is the x column. Okay, then we have two y columns. We have a y column for the zombies and then a y column for the humans. And so like our first point for like zombies will be 0, 1, and then 1, 2, and then 2, 4. So we're going to plot all these points, and then we're going to plot these points as coordinates. Okay, so it's a little tricky. Let's start with the zombies here, and I'll get you started. Okay, so at 0 hours, we have 1 zombie. Well, if this is 10 and this is 5, then 1's going to be kind of down here. So pretty low, kind of hard to see, but it's going to grow pretty fast. Okay, and then after 1 hour, we have 2 zombies. So just a little bit above that. Okay, it's not growing super fast yet. At 3 hours, we have 8 zombies. Oh, sorry, I think I skipped one. Yeah, 2 hours, we have 4. So 1, 2, 4. Okay. After 3 hours, we have 8 zombies, so not quite all the way up to 10. After 4 hours, we have 16 zombies. So 16 will be like a little bit more than halfway between 10 and 20. So something like that. All right, and then after 5 hours, we have 32 zombies. So 32 will just be a little bit above 30. Okay, so that's the pattern so far. Now you're going to keep plotting these points to see what happens. Okay, and that's going to kind of keep going up in that direction. Okay, now let's look at the other population. So this is zombies. And probably what you're going to want to do is use different colors or different symbols for the two different graphs so that you can tell them apart. So let's see, I'll use a pencil for the humans. Okay, now this X column still works for humans, so this is still hours. So 0 hours, there's 4 humans. So let's plot that. 0, 4 would be about here. Okay, after 1 hour, there's 54 humans. So we go 1, and then we go 54 is going to be way up here. Right, so notice it's higher and it's steeper than the other graph. Okay, after 2 hours, there's 104 humans. So 104 will be up here, right? After 3 hours, there's 154. So 3, here's 150, right? Here's 154. Okay. So what our graph looks like so far, well, it's going to be linear the whole time, but it's, you know, we got this straight line, basically, constant rate of change. So I'm just going to connect those kind of like that. Okay. Now you're going to have to keep going. You're going to need to finish the table, finish the graph. These are going to grow. And what we want to see is if the zombie curve, the blue curve, ever passes this guy, then there's going to be more zombies than humans, which means they can overtake the facility. So we're trying to figure out when that's going to happen. We're trying to predict when there's going to be more zombies than humans. If you finish the table first, you'll be able to see where that happens on the table, okay? And then you'll also want to label that on your graph, okay? Now this table, you'll go kind of fill out the whole table, but you won't be able to fit this whole table on the graph. What you will be able to show on the graph is when the blue curve passes the pencil curve. That's what you want to see. So put enough points, make your graph big enough that you can see where this passes this. And again, you're going to have to add another piece of graph paper on the top because notice this is so steep, right? And this is about to get steeper as it takes off. So that's task 2. Or excuse me, that was it's called task 8 on this one. Okay, make sure you label everything. So you should have a title, you should have your axis labels, you should have the point of no return labeled. Okay, make it look nice and neat and professional. Okay, the last part here is to write a function. Okay, we have one linear function and one exponential. So the zombie function is going to be exponential. I don't want to write it out for you because that'll give too much away, but I will tell you what it looks like. We know that exponential growth functions look like this, and we've actually already written one. This stands for initial amount or starting amount, so this is how many zombies you start with. This is your growth factor, B, right? And for doubling, you should know what that growth factor is because we talked about it before. What are we multiplying by in order to double something? Whoops, sorry. I put a 2 up there. That's not supposed to be there. It's supposed to be an X. Or an N or whatever. In this case, I think it's an N that we're using, or H or whatever. So let's write it as an H instead. Doesn't really matter, but. So that's the template for exponential growth. We've seen that before. We saw it in the Z+1 task. So initial amount, growth factor, and then you got your variable, hours. Okay, now human population is linear, right? It goes in a straight line. And so what it's going to look like is something like this. Y equals mx plus b, right? Linear. This is the slope or the constant rate of change, and this is the y-intercept or the initial amount. Remember, y-intercept and initial amount are kind of like the same thing. So you're going to write an equation that has your initial amount, how many humans you started with, and it's also going to have the constant rate of change. What are you adding every single time? What number? Now, again, the variable that you're using looks like it's going to be an h instead of an x, but that's okay. All right, so you're going to have an exponential function and a linear function, and then you're going to take those functions and you're going to write them on your graph. You're going to label the graph. So the curved one is the exponential. You'll write that equation next to it, and then you'll write the equation for the linear one next to that as well. Okay, so this is going to be worth 20 points in the homework, classwork category. So it's basically worth 2 homework assignments. So don't neglect it. Make sure that you complete this and get it in. If you have any questions or if you get stuck, you're welcome to shoot me an email. We can kind of talk it out. But I think I gave you enough hints to get you started. And it's, like I said, similar to ones we've done before. So hopefully you can draw on your experience from previous tasks, previous activities that we did in order to complete this one. Thanks for watching.